So as you were just notified on your screens, this webinar is being recorded and I will share more on that shortly, but I just wanted to let you know that. We are a little past noon, so I'm going to go ahead and get started. Thank you everybody for joining. Alrighty, let me share my screen. So the Virginia chapter of APA is really happy to host this month's Mid-Atlantic Planning Collaboration webinar, High Resolution Land Use, Land Cover, and its Applications to Land Use Planning. We'll introduce our speakers a little bit more as we transition, but I just wanted to provide the CM number here, which is certified for AICP credits. I will also share this in the chat momentarily. Also in the chat, in just a few minutes, I will share the link to our YouTube page where you can find this recording and previously recorded webinars in this series. So there will be times during the presentations in which our speakers will ask more open-ended questions. For that, you can use the chat box. But for the more formal Q&As, which will be conducted at the end of each presenter's portion of the webinar, please submit your questions using the Q&A box. So put those in as they come. We'll be doing it after each presenter throughout. You can also use the raise hand feature to request to be unmuted during the more formal Q&A portions. For that, I will just unmute you and you can ask your question verbally or orally. I will provide other helpful links to APA Virginia's website, to the MAPC website page in the chat box shortly. But I'm going to go ahead and stop sharing my screen so that our presenters can start sharing our screen, and I will introduce our first speaker. But thank you everybody for joining. I think we have a really great presentation ahead of us. Alrighty, so first up we have Sarah McDonald. Sarah is a geographer with U.S. Geological Survey located at the Chesapeake Bay Program office. She is a member of the Chesapeake Bay's Program, GIS, and land data teams and coordinates the land use workshop. She specializes in land change science, including working on the Chesapeake Bay land change model and assisting the Chesapeake Conservancy to map 1 meter resolution land use, land cover, change for 99,000 square mile for a 99,000 square mile region within and surrounding the Chesapeake watershed. Sarah holds dual bachelor's degrees in computer science and environmental science and geography from the University of Maryland, Baltimore County. Alrighty, so I will pass it over to Sarah. And again, thank you everyone for joining.
Thank you, Jillian. Yes, so I'm going to give an overview of what the data is, and then I'm going to pass it off to 3 really great presenters who are going to talk about how they've used the data. So if we go to my next slide, a quick overview. This data was produced cooperatively through a cooperative agreement through EPA with the Chesapeake Conservancy and with the University of Vermont. For 2013 and 2018, we have mapped 1 meter resolution, 54 class land use land cover products. In the image on the left, you can see the white boundaries, the Chesapeake Bay watershed, and the black boundaries show the 206 counties that we have mapped. So you can see all of Delaware and all of Maryland are mapped, and parts of Virginia, West Virginia, Pennsylvania, and New York. This June, we will be releasing an update to these data up to about 60 classes, and we will be adding a 3rd date of 2022 to the mix. The data can be accessed in a few different ways. Hosted on the Chesapeake Conservancy's website, they have 2 web viewers. The first web viewer, an example of which is on the left, shows a slider where you can see our 1 meter resolution land cover and our 1 meter resolution land use land cover for the 2018 time period. That link is there, and that's at the county scale in which you're able to download all data. They also have a second web viewer where they show change, and that change web viewer has 3 panels showing the early date, and the late date of the NAPE imagery, the National Agricultural Imagery Program, 1 meter imagery used to produce the data, and the land use change data on top of it. So you can see where we mapped change, and you can compare it to the imagery and see if that change is really there and did we map it correctly. Secondly, you can see on ScienceBase at the DOI link listed there, the USGS has published a state scale version of the data on ScienceBase. There's not a web viewer there, but if you were looking for aggregated data, if you're interested in multiple counties in your state or jurisdiction, that's where you can go to download it. So an example of what this data is, so this is what the imagery looks like, that NAPE imagery. This example is in 2018, and from this image, you can see forests, you can see agriculture, you can see the developed areas and the roads, there's even an airport there. And if you look at what we mapped, you can see the different land uses. So this is an 18 class aggregation of the data. There's 54 classes that are actually mapped, but we display it with 18 because no one can make any sense out of 54 colors on a map. So you can see the orange is cropland. The kind of lighter tan orange is pasture. We have harvested forest over there in browns in the left. We have natural succession in the bright green. You can see the roads in black, turf grass in this kind of paler greenish color, forests in green. Structures are mapped separately, so you can see structures in red and other impervious in gray. So you can see, for example, if you look at this airport, you can see kind of the airport runways are classified differently than the buildings and differently than roads. So if we zoom in, we can also see, for example, this is the parcel boundaries in white, and you can see with the images, you see a recreational area pretty clearly here, and then you see a series of homes. And if you look at our data when zoomed in this closely, what you're able to see is we've mapped different land uses. You can see the configuration of the land uses here. So in that recreational field, for example, you can see we're mapping turf grass. There's a little structure there. You can see a line of trees along the edge. You can see tree canopy over turf grass, which is that kind of mossy green color, adjacent to the structures in the homes versus forests in dark green and some successive area next to roads in the black. In addition to mapping the static data, this is the full classification. So these are the 54 classes that are actually mapped. You can see a series of water classes, for example, where we separate lakes from the estuary, from stream channels. The developed classes, we map solar fields, we map turf grass, 3 different tree canopy over impervious classes. In forests, we map harvested forests, we map natural succession. We differentiate large forest patches from smaller forest patches that we call other tree canopy. We map cropland, pasture, orchard, vineyards. We map extractive mines, surficial mines in particular, and then we have a series of wetland classes you can see there as well. And we carry this classification through time. So if you, if you zoom in, you can see we are also collaborating with the Conservancy once again, as well as the University of Maryland, Baltimore County, to produce hyper-res hydrography at the 1 to 2000 scale. So that's what these blue lines are. And these data are mapping channel-like features. This data will be released in 2024 with the new iteration of these high-resolution land use data as well. And they are working on a follow-up project to identify flow permanence within these identified potential stream channels. So you can see from here, you can see where we have our mapping. When you combine these data, the types of questions we'll be able to start answering, as well as potentially targeting conservation at a finer scale than we've been able to do so before. And now, over time, we map this data. So you can see, this is an example in Frederick, Maryland, where on the left is 2013 imagery, and on the right is 2018 imagery. And you can see on the left, it looks like you can see it's starting to be developed, as well as you can see that it probably isn't active agriculture at the time, but was probably used for agriculture some point prior to this. And then by 2018, you can see it's well developed at this point, right? It's a new neighborhood, it looks like. And how we map it is the University of Vermont maps land cover change. So they're detecting the new structures, right? That vegetation became structures, that vegetation became roads. That barren land that was construction became grass. And we translate that, the Conservancy and USGS translate that to land use change, where you can see anywhere that there was land cover change, we mapped land use change. But in addition to that, you can see the footprint's a little bit larger, but you can see in the circled areas. We've added the difference between no vegetation change. So areas that looked like they were at once agriculture and were vegetation in our early date were grass. So still vegetation in T2, but how they're being used is they're no longer active agriculture, right? So our land use data set captures these changes in use in addition to changes in cover. And just one more example of this is we can see in this date an area that's currently undergoing development. And in the next time period, you can see that it's become developed. So now we have a whole new neighborhood here. And if we look at what we mapped in our early date, we can see that we're mapping it, and this classification is that yellowish color, which is pervious developed. And in our true scheme, this is probably transitional barren in our full 54 class schema. You can also see if we associate that with riparian areas, this is at the 1 to 100K scale, the blue lines and buffered about 100 feet. You can see the adjacency to this change to the streams. And if we look at our late date, you can see now we're mapping it as a whole new neighborhood. And then from here, I would like to take a few minutes. If you could go to menti.com and enter this code. If we're able to drop this in chat as well for folks to be able to click the link. I would just like a little bit of feedback from you all, mostly asking questions about, have you heard of this data before now? Have you used this data before now? Those types of things. So we'll take about 5 minutes to answer some questions. Yes, or you can use the QR code with your phone. Thanks, Jackie. Yes, and can we drop the passcode in the chat as well for folks? Perfect. Thank you, Jackie. All right, we'll give it maybe 10 more seconds and we'll go to the next slide. All right, perfect, thanks. All right, so let's go ahead and ask our first question. So just a little bit of feedback of kind of where are you calling in from? What area do you serve? What jurisdiction do you represent? So if you work for a county, what county? If you work for a state, what state? All right. Thank you for that feedback. I see a lot of West Virginia. I see a lot of Maryland, Pennsylvania. I saw some North Carolina in there. So thank you for that feedback. Appears to be slowing down, so let's hop to the next one. All right, so before today, prior to this webinar, have you heard of this data, never heard of it but never used it, you've used it? Or if you have some other scenario, you have a free response option as well. Okay, I see a lot of folks haven't heard of it. Some have heard of it and haven't used it. Some have heard and plan to use it. I see 19 folks have used it, so that's exciting. And one other response. So thank you for that feedback. Can we go to the next question, please? Based on what you know about the data and kind of the very brief overview I gave of it, do you see yourself potentially using this data or being useful for kind of your day-to-day work? Right, I see a lot of yeses, so that's exciting. A lot of I'm not sure's, that's okay. Yes, but not sure how to use it, okay. All right, if you did answer yes to the last question, do you have any ideas on what you would see yourself using this data for? See lots of different use cases, so that's very exciting to see. All right. Looks like the responses for this question have slowed down. Do we have any more in this section, Jackie?
No, I think that's it.
All right, perfect. Thank you. So that concludes my kind of overview, my introduction to the data. I'm going to go ahead and pass it off to Jillian to introduce our next speaker. Thank you all so much for coming and participating in the poll.
Thank you so much, Sarah. So next up, we have Bill Mahoney, who is a project manager in Howard County, Maryland's Office of Community Sustainability. He currently leads the Ecosystem Services Work Group as part of Howard's County Climate Action Plan implementation and works on forest conservation, stormwater, and green job skill development projects as well. He is currently working with several county departments to develop methods for reaching Howard County's, goal of 50% tree canopy by 2030, and will be using the Chesapeake Bay region high-resolution land cover data in that effort.
Great. Thanks, Jillian. Thank you all for being here this afternoon. Let me get my screen shared here. All right. And are you able to see that? We're all good?
Yes.
Okay, great. All right, let me just move a couple things around here so I can see the screen. Okie doke. So I was glad to see some of the responses to the questions a few minutes ago, because this might be appropriate for some of you to get a little bit of a starting point for how you might want to proceed on some of your own projects. So I'll be talking about how we use this data to set climate action plan baselines and goals. I should point out we're also beginning to use this data in other plans like our LPPRP, which is the Land Parks Preservation, something like that. Some of you are probably familiar with in our general plan. But today we'll be mostly talking more about our climate action plan. So we started in 2021 trying to find a baseline for tree canopy and forest in Howard County. We'd been getting a lot of pressure to establish some forest and canopy goals, and we didn't really know even where to begin. And then just last year, we launched our climate action plan, and I'll talk about how this data helped us do some things there. And then just about 2 weeks ago, our county executive kind of forwarded one of our climate action plan goals up by 15 years. So we are now looking to have 50% tree canopy by 2030 instead of 2045. So we certainly have our work cut out for us, and hopefully this data will help us get to where we're supposed to be by then. So in 2021, we worked with the University of Maryland, Baltimore County to get an assessment of our tree canopy coverage and our forest cover. So that took some behind the scenes kind of work, some prowess with GIS that I frankly don't have, and we weren't able to get help from our people internally at the time. So luckily UMBC was willing, had the bandwidth at the time to help us out here a little bit. What we requested from them was total tree canopy and total forest cover for Howard County. We also wanted to know our tree cover and forest cover per parcel throughout the county, so that we could click on a map, and on any given parcel, we would know how many square feet of canopy, how many square feet of forest. Then we also wanted to have some data breakdown about county tree cover by land use. And lastly, we have a green infrastructure network, which kind of means different things in different places. But for us, a green infrastructure network is we have a hubs and corridor system for wildlife and plants. And basically, the green infrastructure network is a map of our best ecological areas, our largest ecological areas, and the connections between them. And within that, there are some areas that we think were probably suitable for planting. So we wanted to get an idea of exactly where those areas are. This graph on the right-hand side tells a couple stories. You'll notice there's 2007 data on the far left. We had the University of Vermont back then do a study for us that came up with the very convenient number of 50% tree canopy cover at the time. And then while that data does not relate perfectly to the 2013 or 2018 data, it's fairly similar. So we've still chosen to include it in some of our material. But some of the other things you can notice here is we have TC is total tree canopy. And then we have soft canopy just below that, which would be canopy over anything that is not impervious. So you can see that there's about a 2% gap here, that about 2% of our canopy is over impervious. And then lastly here, you'll see that we consider, based off the analysis we asked UMBC to do, that the vast majority of our tree canopy is forest. But however, we know that's not true. What happened there was we put in the Maryland Forest Conservation Act's definition of forest, which is an appropriate definition for a Forest Conservation Act, but would not really, to most people, represent the definition of a forest for size. So we have chosen to essentially ignore the forest cover data moving forward until we find a better definition we're happy with. And then we'll probably begin setting baselines for what we think our actual forest cover is. So here's just a little bit more information. And really just on the left here, I want to point out that in the report we got from UMBC, they sliced up the data a lot of different ways for us to reveal different patterns, different ways of considering the data. Here we have a look at the percent of land in each land use that is either an existing tree canopy, could be planted to become tree canopy. Possible impervious tree canopy is a sort of pretty narrow area that I am frankly not certain how we came up with, but I imagine it uses some of the 54 classes. These are areas that with some small change might be plantable, but are sort of on the margins of plantable. And then the not suitable category is things like open water, airports, roads, areas that are just absolutely not suitable for planting. Then on the right-hand side here, you can see, and this probably should have been its own slide, but everything in green here and yellow is our green infrastructure network. And if you're familiar with Howard County at all, you would know like the Middle Patuxent Environmental Area here, Centennial Lake here, Patapsco State Forest all along this edge, and Patuxent State Forest, and a lot of WSSC on this southern border. Basically, this is our green infrastructure network in green. Black is tree canopy, and the planting potential is shown in yellow. So this was a start for us to figure out where we could fill in the gaps with our tree planting initiatives in our green infrastructure network. And I will touch on that a little bit more later because we're hoping to improve that. Okay, let's see here. And then we wanted to make the products available to the public. So we have an interactive map now available that shows the 2007, the 2013, and the 2018 data. This is just a little snip from that shows where a major development went in, I believe that was between 2013 and 2018. So we have this interactive map that is available to the public and also to our planning staff, or really all of our staff. And then our full report from UMBC is also available online. As I said, there's more in there than just the land use analysis, the green infrastructure network analysis. There's a number of other ways of looking at the data that don't quite have time to go into right now, but we found this to be an interesting tool. People haven't really found much of a way to use it internally for planning quite yet, other than maybe verifying coverage in the past. But still, it's something we're developing additional uses for, as I'll touch on in a few minutes here. So just last year, with the launch of our Climate Action and Resiliency Plan, we set a goal of having net zero carbon emissions by 2045. Important to note net zero, right? Because it's nearly impossible to go zero emissions. You'll almost always have backup generators, et cetera, that'll need to emit. So we needed to know what is our carbon offset. And to do that, we looked at a couple different tools, and I'll show that in just a minute, but we found that we were removing 252,000 metric tons of carbon equivalent, and that represented about 7% of our emissions. So we had about a 7% offset from our current county emissions. I believe that is for the whole of Howard County, not just government operations. And then we also set a goal within our plan to achieve and sustain 50% tree canopy. Initially, that was a 2030 goal. Then we got some updated data that said we actually were already at 49.6% tree canopy. So we decided to change that to a nice round 50. And I will touch on that a little bit more in a moment as well. This original 49.1% was the number generated by UMBC. We got 49.6 from a lot of the same folks who have worked with this data, just like 2 years later, put out some fact sheets. And I imagine something in the slight different handling of 54 classes of data could account for those differences, but that's something I want to look into more in the future. A couple of resources that I think people might find helpful that utilize these data sets. On the left-hand side here, we have ICLEI, which is, so I'm moving some stuff around here, the International Council for Local and Environmental Initiatives. has a land emissions and removal navigator tool, and it provides a map that shows changes in land use. It also provides a matrix of land use change, so you can tell of all your different land cover and land uses, how have they migrated to different land covers and land use over time, which is pretty interesting. So I want to point out that there's multiple products within ICLEI's tool here, because we see a pretty big difference here between their estimates in our net carbon sequestration and what was produced at ChesapeakeTrees.net. We've got almost a twofold higher number from ICLEI's product. I have some guesses as to why that might be, but I don't want to venture them right at this moment. But the point is that regardless of what these numbers say, we're looking at them, at least for us, in a directionality sense. So while we may not have absolute confidence, and we really can't in either of these numbers, if we continue to use the same methodologies and track with the same organizations in these tools, we should at least be able to see which way we're moving. So let me, and you guys will have access to the presentations, but here are the links to, with Chesapeake Trees, it's really, I think there's a lot more going on that website, but what I'm familiar with are these printouts for every county in the Bay region. It reveals some pretty interesting trends for your local canopy and forest. And then on the left here, ICLEI has just a different suite of outputs from a pretty simple to use online tool. And again, while there are differences, we still find them pretty useful, and we'll continue to use both of them and probably other tools in the future. I'll point out that ICLEI's tool uses the NLCD data set for forests, and it uses the Chesapeake Bay region data for trees outside of forest. And that honestly, I'm not entirely sure. I believe that the iTree calculations and the ChesapeakeTrees.net over on the right-hand side, I think that was all using the Chesapeake Bay region data. So that'll account for some differences as well. This is just a reminder for me to talk about that we have begun to try to investigate ways to improve tree planting to address heat vulnerability, heat island effect in our county. Unfortunately, we kind of lost touch with our developer for this app, and we're not entirely sure of the weighting of everything here. What we have is mapped in blue here is tree canopy existing, but on the back end, there's also supposed to be considerations for impervious surface, as well as the Baltimore Metropolitan Council's demographic and socioeconomic data. The idea is to refine this map in the future to have it help us understand where the best bang for our buck is for planting with respect to heat island effect. Anecdotally, we know Route 95 and Route 1 run right through Howard County, and that's kind of how we've been addressing heat islands, but we're looking for a more sort of data-driven approach rather than kind of just what we think we see. So we're not really there yet with this, as we don't quite understand our own data, but we're looking to improve this tool moving forward. Just a couple notes now, again, on the recent tree canopy goal, which improves upon, I suppose, our climate action plan goal. If we accept that we're at 49.6% tree canopy now, that 0.4 increase that we need is 640 additional acres of planting, which is certainly going to be a challenge to find. And that's going to be a net increase. And I think most of us know we're always losing canopy incrementally along roadways to invasives, along a lot of development to invasives. And in some counties in Central Maryland, we're having a pretty weak recruitment class in our canopy due to deer pressure. So we have to consider that it's probably more than 640 acres needed. So we're increasing our funding for forest maintenance and canopy maintenance to kind of hold the line while we try to plant more. And we're trying to improve our plantable area maps. We're currently working with the World Resource Institute to use this data and subtract, or to really further what the Chesapeake Conservancy has already created as a plantable area maps, and net out some additional areas using Howard County specific data like our ball fields, our stormwater ponds, gas line data, various things that might not exist in this raw or plannable area map, so that we can really have a much higher level of expectation out of it. If you just say that a plannable area map is anywhere that there isn't currently canopy, then that's going to be a nearly useless tool for you. There's so many areas that from the air look like you should plant trees, but then once you realize that it's a reserve septic system or something like that, you realize you can't have trees there. Stormwater ponds and berms are another area that pop is plantable a lot as well if you don't net them out ahead of time. So after we get this plantable areas map back from WRI, we are going to do additional analysis, all kinds of things by watershed, by council area, which areas have the most unplanted buffers, et cetera, and just try to figure out where really our planning goals should be. But I think the reality of the situation is with 640 acres to plant in 7 years, we're going to probably be doing a full court press on all the different land use areas. We'll also use the data moving forward to consider setting canopy goals for each of our watersheds in the county. So this is a pretty broad overview. I'm not a particularly tech savvy person. I'm more kind of negotiating between our administration and some of our directors as far as that we should be using this data. And yeah, so far I think we've gotten some good leveraging out of it now that we can actually have goals that are based off of something. So it's early days for us here, but this has been really helpful to get us at least some starting points within our various comprehensive plans. So with that said, thank you all for listening, and my contact information is in the bottom left there in case anybody wants to contact me with any questions outside of this.
And Bill,
Yep.
it looks like you have a couple of questions.
Okay, yeah.
You wanna...
Oh, right, here we go. Yeah, so no, you don't have to be a member to use the Learn tool. I meant to mention that, so thank you very much for bringing that up. And then, are we working with municipalities on their land development code to assist in increasing plantable land? Sort of. So we don't have incorporated municipalities in Howard County, but we have just gone through a major Forest Conservation Act overhaul. And so that has, created some changes in our development requirements that have had some mixed results, but we have increased the obligations generated from clearing. So we think right now, after only changing the act 3 years ago, we think we're getting pretty good results, replanting far more than we're getting cut down, but we also recognize there's a difference in the value of young trees and older trees. And then the next question, how much canopy does solar eat? That is a fair question, and I cannot tell you off the top of my head, but that is an exercise we could perform and find out more about that. So, yeah, what do we got here? Thank you. We're being asked to do something similar. Yeah, so feel free to reach out if you have any more questions. But yeah, this is, like I said, kind of early days for us, but still, this has been a really excellent tool for us to get started.
Thank you, Bill. And I will just note that while we are doing questions in between each presenter, there will be a few minutes at the end in case you think of something towards the end of the webinar. So next up, we have Deb Sward. Deb is the Assistant Manager of Geospatial Data and Analysis at the Maryland Department of Planning. She specializes in developing GIS models that support land use and environmental planning, including a new model to automate the development of a statewide land use map. This effort is made possible by the availability of statewide parcel polygons attributed with tax assessment data, as well as the Chesapeake Bay Program's new high-resolution land use land cover data. Since joining MDP, Deb has overseen other efforts related to GIS data, production, and mapping, providing GIS technical assistance to local jurisdictions, and helped develop standards for aggregating GIS data from multiple sources. Before joining MDP, she worked as a consultant environmental planner, primarily helping state agencies meet National Environmental Policy Act requirements for infrastructure projects. And she holds a master's degree in urban studies and planning from the University of Maryland at College Park. So I will hand it over to Deb.
All right, thanks so much, Jillian. And we really appreciate the opportunity to share what we've been working on to finalize the statewide land use map update. And I know for folks that have used this data before, many of you have reached out to us about the project, and I'm happy to report that we're moving full steam ahead. And we're actually in the final stages of our internal quality control process. So we're really nearing the finish line here. So appreciate your continued interest in the project and all the feedback that we've received on this so far. And for those of you who are new to this one or maybe haven't worked with this data before, this is a statewide land use map for Maryland that shows the general locations of residential, commercial, industrial, institutional, and other developed land statewide, and also generalizes residential density across the state according to a common yardstick. A couple ways that this data set has been used. Local jurisdictions have mapped existing land uses in their comprehensive plan using the data. Environmental planners have done pollutant loading analyses by land use using the data. It can be used in conjunction with development capacity analyses to see where development capacity or pressure exists on rural resource land and target land preservation efforts accordingly. And then finally, for NEPA planning, we've seen it used to look at the potential land use impacts of a major transportation project, for example. So this is our historical classification scheme, which has historically been a land use and land cover map. It divides the state into two areas, urban or developed areas, and then the remaining undeveloped kind of rural resource land. And among the developed uses are the uses I mentioned before, but also residential density is divided into 4 different categories, from very low density that with lot sizes ranging from 5 to 20 acres up to high density residential with more than 8 dwellings per acre, like kind of your garden apartment and above. And then we also historically included some subclassifications for the undeveloped resource land, things like agriculture, forest, water, wetland. As you saw in Sarah's presentation, the Bay program has since taken on mapping a lot of that stuff at a high resolution. That data set's really well vetted. So rather than reinventing the wheel, we're going to take out all the subclassifications in our map and just focus on mapping those developed land uses. So we're really adding value instead of redundancy here. So as a follow-up to that, like how is our data set different from the Bay program's data set? So as you can see on the left side, this is like a snippet of our draft land use map, and you're looking at a residential area here that's kind of shaded in yellow, this residential subdivision. We're really looking here at like how the land's been subdivided and built for the most part. And then on the other side, you can see a lot more detail about what's happening within those parcels, as Bill and Sarah showed in their presentation. So within a residential parcel that's shaded yellow on the left, you can see where there's forest, for example, or agriculture or turf grass structures, things like that. So we hope that using these two maps together, you can do some really interesting analysis and glean some interesting things. Another thing I just wanted to point out is that development as defined in our data set differs a little bit from development as defined in the Bay program's data set. So our numbers will end up looking a little bit different. And just a couple examples, like for example, rural areas or like single family homes on really large parcels greater than 20 acres are typically treated as rural in our project because we're looking more at like rural to urban conversion from like a parcelization standpoint. In the Bay program's land use map, all the impervious roads and structures are rolled up into development for their purposes. So it'll be treated differently in each map. And then another example is that we have a couple other they have a couple other classifications that we don't incorporate the same way, like utility or rail lines are mapped. Those take on the land uses of their surroundings, while in the Bay program's map, they kind of have their own pervious developed category. So they're just a couple of examples of how our projects differ to keep in mind when using the data. So I just wanted to be clear about what some of our inputs are for the project. two critical inputs that allow us to do this mapping statewide are the GIS parcel polygons that are attributed with tax assessment data. And I think previously we had the GIS tax assessment in point format rather than polygon format. So obviously that allows us to do a lot more now that we have the statewide polygons and also the Bay Program's high resolution data. We're also incorporating local land use data from county and municipal jurisdictions where available, incorporating some data from the 2010 map and other ancillary data. And then I'm going to be going through a couple methodology updates throughout the presentation for those of you who have used the data before, but I just want to have them here all in one place. And I mentioned previously we're focusing on mapping just the urban or developed land uses, and we're doing that as of 2018 just to match the vintage for the Chesapeake Bay program, and hopefully we can get on that similar sort of production schedule going forward. We're also including the entire roadway network within the transportation classification. So previously, I think they were only able to include highways, but now thanks to the Bay Program's impervious roads category and also some other work that MDP and local jurisdictions have done to get full rights-of-way coverages between parcels, we're able to map the whole thing. And later I'm going to talk a little bit about how we're able to further generalize our very low density residential uses and also automate and standardize this effort. And that's all that automation and standardization is really made possible by the ability to use this high resolution data. So our land use map is generated in two separate steps. It's a pretty complex process, but I'm distilling it here into just kind of our foundational concept. So first we have to decide what class is classified as development, and then to figure out what the classification is on each parcel. So what we really start with is that attributed parcel polygon. We look to see if the tax assessment data shows that there's like a residential or commercial building or some other description showing that there's some sort of residential or commercial value on the property. If yes, under most circumstances, it typically goes to development. If not, is it a park or open space or extractive use, which as you saw in the earlier slide, those are classified as developed, at least the most intensely built portions of those parcels. So we classify those within the urban and open space categories. And then there's this other tricky classification where there are some parcels that may not need a tax ID for tax purposes, or we just don't have necessarily enough attribution to know if it's rural or urban parcels. So these are areas where the Bay Program's data helps us identify these other parcels where structures or impervious are present, and then we can do a little bit more analysis with the ancillary data. So if we identify one of those parcels and then we see that there's a rural parcel description and we have some data showing the location of poultry houses, that's going to get classified as undeveloped resource land because we assume it's not part of it's part of the rural landscape and we're supporting rural uses. But if the local jurisdiction data that we have or the 2010 data set shows that there's some development there, like maybe it's a parking lot for a condominium facility, for example, then it will go to development. So this is how both the Bay Program data and the data from local jurisdictions really helps us refine our process. And then once we have those classifications, we have kind of a complex algorithm that assigns a preliminary land use to each parcel. We have a couple parcels that are kind of manually verified that we keep track of, things like golf courses and stuff that's a little tricky to capture just from the tax assessment data alone. And then we also enhance all of that with local data, and local jurisdictions have an opportunity to review all the individual classifications as well. So once we have those classified parcels, the final step is to generalize the residential density. So you can see on the left, all the single family homes are just classified as single family homes, basically. And then based on lot size and some generalization techniques, we're able to group them as from very low density up to that high density classification. We're going to generally keep the 2010 generalizations where there's no new development, but in areas that have been newly built in their immediate vicinity, those are going to be revisited and generalized using standard procedures. I mentioned before, we're going to do a little more to generalize the very low density residential uses. So in both the left and right image, there are parcels that have single family homes. But on the left side, they're a little bit more in line with the kind of urban classifications we were talking before. They're part of subdivisions. On the right side, those are generally agricultural areas and supporting agricultural uses. So we're using some clustering techniques to try to capture what looks like on the left is very low density residential, and on the right hopefully folding all of that into the undeveloped and rural resource landscape. And then lastly, this is a critical thing that the Bay Program data helps us do and automate, is to determine the developed extent, particularly on these very large parcels that typically have rural and urban uses on them. So as you can see, the parcels that are about 5 acres and smaller that have a building on them, those tend to get filled out as developed parcels or urban land. For the remaining, particularly the commercial and other non-residential uses, we're capturing just the developed parts of those, and that's where we incorporate the Bay Program's developed extent to help us delineate where the development actually is occurring on those parcels. So just to close out, so as I mentioned, we're nearing completion of this project. We still have to review the classified parcels with local jurisdictions and stakeholders who want to make sure the Bay Program is comfortable with how we've incorporated their data. And then after that, we incorporate the comments. We're going to release a beta version for public use and testing and additional feedback. So we figure there are still a couple things we want to work out with this project and improve over time, but we think a lot of what we have is going to already be very helpful to people. So we don't want to withhold that in the meantime. And we're just going to, put a couple of caveats on there about things that we still want to look into for further exploration. So a couple things is that we built a model to incorporate the local data to the extent possible. But when we reached out for that local data, we're just like, give us whatever data you have. So it's all, some of it was historical data, or using different classification schemes, or different levels of generalization. So maybe we can in the future provide the option to send what folks have, or also to even reformat some of the data so that we can incorporate even more local data. So that either way would be possible. And then we also want to look a little bit more into these dual rural and urban uses and areas that have solar facilities on agricultural land. Right now, it's kind of an automated process that relies on tax assessment attributes. So we want to look into seeing how we can parse some of those a little bit more in the future. And we welcome any feedback on the best way to incorporate solar in our map and how that should be classified. If it should be its own category or in that open urban land category, for example. And then finally, it's not possible to compare the new map with the 2010 map just because of the methodology changes that we've done. So we'll be looking into ways we can assess change over time, given improvements in methodologies and GIS data over time. So I think that's it for me, and please feel free to reach out with any feedback or questions you might have.
Deb, it looks like you do have a few questions in our Q&A box, if you want to take a minute.
Sure. I think I need to end sharing so I can see them. Okay, great. Have any state DOTs use the data to calculate the extent of forest loss resulting from state highways and interstate? Yeah, so that's a good question. I'm not sure if our, I wonder if the foundational land use and land cover data would be the best data set for that type of use, since ours kind of pulls out some of the developed lands and we don't always have the some of the rights of way and stuff like that, even though we have a general sense of the rights of way between parcels, those aren't survey quality and stuff. So I'm wondering if an analysis using the original land use and land cover data may be helpful for that. Though our map would definitely be helpful for looking at where different types of developed lands intersect those things. And we always are welcoming feedback on how we can improve our map for other uses like that as well. And then has anyone vectorized the Virginia raster LC data? So I'm not sure for Virginia. We did do some vectorization as an input to this project, but our map is currently using a raster. We ended up resampling ours to 5 meter just to do the analysis for this testing phase. So I'm not sure about Virginia though.
Alrighty, well, if you think of any more questions for Deb in the next few minutes, you can go ahead and put those in the Q&A box for later. But I'm going to introduce our last speaker, Scott Heidel, who served as a military intelligence analyst in the U.S. Army's 3rd Armored Cavalry Regiment. During his combat deployment, aerial imagery enhanced with specialized tradecraft became a highly useful tool to strategically plan and communicate multiple objectives in an environment that demanded results. Following his military service, Scott majored in wildlife and fisheries biology at California University of Pennsylvania. Scott then continued his public service by joining the Pennsylvania Department of Environmental Protection and working in various programs, including TMDLs, 319, and the Chesapeake Bay Program, all of which require results-driven strategic planning and effective communication. So I will hand it over to Scott.
Thank you very much. And can you see my screen?
Yes.
Okay, excellent. So I'm going to be talking about planning and multiplying local subwatershed restoration throughout the Bay watershed. And what I mean by multiplying local subwatershed restoration, it's using the technique that I'm going to present today in multiple subwatersheds throughout Pennsylvania or the larger Bay watershed. So to start off, you really need to figure out who's going to lead the effort. And in Pennsylvania, what's been working for us, the county conservation districts take the lead, or our countywide action plan coordinators. They tend to have a little bit more sway over the agricultural operators with regard to compliance visits with E&S plans, nutrient management plans, things like that. But they also have the links in with our grantees, and that moves into the next point. Have you built positive relationships with your local restoration partners, such as Trout Unlimited and watershed associations? They're the ones that end up getting the grant funds and can do the restoration work. And then have those partners built a trusting and cooperative base of landowners to implement the BMPs. Because without the landowner support, you're not going to get the BMPs put onto the ground and implemented. And if you have some no answers to these, you really got to start thinking about doing some outreach. And here is an example, and this will be sort of a theme that runs throughout this presentation. This particular project site, here are some of the partners that were involved. You can see there are local contractors involved here that are from the Amish community. That was one of the things that the landowners in this area really requested. They wanted to see some of their own involved in the work. But we have federal, state, county, nonprofits, watershed associations, you name it. This one really was a shining example of teamwork. Okay, and then watershed selection. Here's where you really want to ask your restoration partners, what they have in mind, and if there's anything interesting that the public would really get behind, like are there hellbenders or freshwater mussels. And in this particular watershed that I showed, we have the threatened Chesapeake Bay log perch, which is a small, sort of like a darter species that is clinging on in just a handful of tributaries to the Susquehanna River close to the Chesapeake Bay. And then another thing to consider is what's the level of impairment and the area of operation. So if you're taking on a very, very large watershed that's really, really impaired, you're going to be putting in decade after decade after decade and potentially spinning your wheels and not getting very many successes. So we suggest paring that down and look at, around a 10 square miles area that has
It looks like Scott might be frozen. Is he frozen for any other speakers?
Yeah, he looks frozen.
Alrighty. Well, we will wait just a moment to see. Sorry, folks. Let's just give Scott a moment, see if he can reconnect.
Some really interesting already sources of aquatic life to recolonize data management practice, implementation opportunities, fence out and put a buffer in, stuff like that.
Looks like we lost him. Do any of the other speakers have any commonly asked questions that you think the attendees could benefit from learning just while we're waiting?
One
Looks like
follow-up
Scott's back. Sorry to interrupt you,
Okay.
Sarah.
Oh, no, you're good. Go ahead, Scott. Can you hear us?
Yes, I apologize.
No worries. Glad you're back.
Thank you very much. Can you see that where I left off?
Yep.
Okay, awesome. So yeah, we have been having some very interesting computer issues here. So back to the presentation. So with the Model My Watershed model, that gives you an idea of what the watershed land uses are, the percentage of those land uses, the pollutant loads that the watershed is generating, and then you can also run BMP scenarios to reduce those particular pollutant loads. Okay, here's an example from the integrated report. I simply drew over the particular watershed that we want to look at, and then it gives you this export file of the different sources and causes and the land uses that it's designated as. And here's from Model My Watershed. Again, this is hand drawn into that watershed, but these three particular tributaries, as they were the main focus of our restoration project. And you can see that we used the 2019 land cover, and it breaks out things like cover crops, hay pasture, and your forested land uses. So this is clearly agriculturally dominated, but there are some areas of forest along the stream. The goal was to fence out livestock and extend those forested areas out. Here's some more tools that you can use. So EPA's Water Resources Registry gives you things like riparian and wetland restoration opportunities graphically. And then what we were focusing on today, the updated high resolution land use layer from USGS. And this gives you the land use changes, buffer implementation, things like that through time. And one of our funding sources that has a nice GIS layer is the most effective basins layer. And that prioritizes funding into disadvantaged communities. So this is a screenshot from the Watershed Resources Registry. And the areas that are highlighted in green are areas that are prime spots to put in riparian buffers. So they're currently lacking. The areas in orange are potential wetland restoration sites. Again, excellent uses, excellent pollution reductions, and green infrastructure to restore wetlands. And that initial slide that I showed with the panel that showed all of our partners, this is that project area. So here's where we get into a little bit of the high resolution land use imagery and the change through time. You can see over here that this is pre-BMP, pre-restoration. This is cutting through legacy sediment that was a couple 100-year-old mill dam that got breached. And then this is during the construction. You can see that there was some stream restoration done. A little bit better sinuosity was put in place instead of the zigzag slashing through the legacy sediment. And here you can see the buffer has been established. The cattle have been fenced out of the area. And again, the buffer is being established and extended in here. Now, this is what was detected as the change, this highlighted area. So it did not detect this large buffer, but that is something that we're working on. And here again, this is a way more zoomed in version of what Sarah had presented. This slide bar can, slide across here and it can show you the percent change or the difference. It did not pick up that newly established buffer again through here. And this is an example of the most effective basins layer. This is where you have some funding. The area that we're working at is generally down here. It's much more zoomed in than that when you actually get to it. So this would be Lancaster County in Pennsylvania that is really, really one of our best partners to work with. They're doing so much extraordinarily great work, and they're getting some great reductions in pollutants and establishing a lot of buffers, getting cattle out of the streams and restoring their waterways. So getting into the actual work of it, the design, implement, and document, we do have additional information on our website, the DEP website, about how we look at watershed restoration in general, the tools we use through the TMDL process, the advanced restoration plan process, the watershed implementation plan process, all the way down through to how the grant work is done to get nonprofits and watershed associations the money to do the BMP implementation. And one of the key points is when you do isolate your watershed that you plan to work in, saturate that watershed with BMPs and attention. So cropland BMPs significantly reduce pollutants. The majority of the pollutant load in an agricultural watershed is going to be coming from the croplands. However, the livestock must be fenced out of the streams and the natural floodplains restored for aquatic life to recolonize sufficiently enough to trigger a delisting assessment. So you can do all the work in the world in the croplands, but if you have cattle walking in that stream, you're going to have a really hard time getting everything back in order and getting the macroinvertebrates and fish to recolonize. And as you're doing this, you have to conduct pre and post BMP monitoring and modeling. So you can not only track numerically what's happening through your modeling, but also what's actually taking place with the bug community, the fish community, the chemistry, the habitat, things like that. And one really important piece of this that a lot of people forget, take pictures at every step of the way. That way you can really document what you've done. And here's an example of a USGS, or excuse me, a United States Fish and Wildlife Service design that was in that area that I showed initially with the sign with all the partners. That picture was taken here, but this is that tributary that leads into it, and this is the main stem of Fishing Creek. And here is after the stream restoration was done, moving downstream towards Fishing Creek, planted a whole lot of native trees and shrubs. You can see the cattle have been fenced out. So this is rebounding at this point. So again, back to that planning and multiplying restoration, the local restoration fits well into countywide action plans, most effective basins, local TMDLs, and advanced restoration plans and WIPs, as well as the larger Bay WIP. So we've been doing a great job of getting lots and lots of BMPs throughout our part of the watershed, but where we really decided that we needed to focus our efforts to get local restoration and local delistings was in these smaller watersheds. So we plan to do a lot of these small watersheds, but throughout the watershed to help to restore the bay, but also get local restoration as well. And here's just some of my contact information.
Thank you, Scott. It looks like you have a question from Kevin.
Okay.
I can.
Yes. So the question was, have you made use of the CAST system? So if you're referring to the Bay model as CAST, yes, we definitely, my section actually reports to CAST for the progress that our state has done every year, and we're in the process of doing that right now.
Thank you, Scott. Attendees, feel free to put any questions you may have thought of throughout the webinar in the Q&A box now. I will hand it over to Sarah, who I believe will be doing some closing remarks. But again, we have plenty of time for questions. So if you think of anything, go ahead and drop those in the Q&A box.
Thank you, Jillian, and thank you to all of our presenters. I'm going to take a couple of minutes to give a quick overview of our land use work group at the Chesapeake Bay Program, which I coordinate, and Casey Filipino, who is on, is our current chair. just a quick overview. What our work group does is we meet quarterly for a couple of hours, so 4 times a year. We oversee a lot of things relative to land use, which is not surprising. We are really involved in making decisions relative to the 1 meter land use, so approving the classification schema, and getting the word out for stakeholder review of the data before it goes live, to give individual counties time to review the data and give feedback before we officially publish it. We work on other data, including how this information, speaking of CAST, how this information will be treated in the CAST model for modeling purposes. We also talk about land use forecasts using the Chesapeake Bay land change model, which is designed to forecast land use change over time for different scenarios, including growth management, for example, or forest conservation, and assess kind of those changes in land management policies and calculate and estimate the amount of effect that would have on nutrients and sediment, for example. So those are some of the things that we talk about. I'm not going to read these full goals, but they're here for you to read. These are our kind of guiding goals, mapping land use, and engaging local governments and other work groups and federal and state NGOs, et cetera. And we are working on now, we have a call for nominees. So we currently have 3 at-large member positions open, as well as a co-chair. We can give, if you're interested, you can reach out to Jackie or myself to talk about it more. So those are official roles that we have open, but I would like to emphasize that all of our meetings, as all the Bay Program meetings are open to anyone to join. So you can join and participate if you're interested, to see if that's something you're interested in joining officially as an at-large member, for example, where you can kind of help guide the work group and identify, you know, how this data can be used for locals, for local planning applications, as well as helping influence, you know, do we need, you know, are there certain land uses that would be really helpful for us to map that would help meet all of these goals, and things of that nature. So if you're interested, feel free to reach out to any of us, as well as you can always search the Bay Program website and just Google, you know, Chesapeake Bay Program Land Use Work Group, and all of our meeting information, including links to the meetings, will be publicly available there. And on that note, I just have a couple of closing questions for everyone. If you are willing to enter the Menti one more time, we have a few kind of closing questions. These are really helpful for us in designing the land use and identifying improvements that we can do to future iterations of the data to make it more useful for your needs. So I'll give you guys a minute here to join. Yep, and as Jackie mentioned, it's the same info as same link and same code that was used for the Menti at the beginning of the presentation. Right, have these been dropped in the chat as well, Jackie?
Yeah.
All right, perfect, thank you. All right, if it's in the chat, we can go ahead and go to the first question. Some of these will be familiar. Some of the 2 of them, I think, are repeats from earlier, to kind of gauge, now that you've seen the data and you've seen how some folks have used the data, do you see yourself using it now, now that you kind of have an idea of how it's been used by others? Okay, our bars look like they're not changing too much. So I see a lot of yeses, which is exciting. We see some not sure yets and a few no's. All right, can we go to the next one, please? So this question was asked earlier as well. So if you answered yes to that previous question of you see yourself using this data, what ways do you see yourself using it? You can also kind of, if you'd like, are there new ideas that you have now that you've seen some of the other ways folks have used it? All right. Thank you for those responses. I see lots of different ways to use the data. I also saw one comment that will be useful and I think captured in this next question of if you don't see yourself using the data, why is that? So if it means we didn't map your jurisdiction, do you need your full state to be mapped in order for it to be used for you? Things like that. That's all useful information for us to know. Okay, in a different state, I see North Carolina. Include the entire state. Yes, the data are downloadable in both county format and in the mapped portion of states are also available, which we can drop those links in the chat for you. Okay, I see vectorize the data sets. By vectorize the data sets, is there a certain scale in which you want the vector format of the data to be in? Is this similar to what Deb showed in having parcel level data? Or the spatially explicit 1 meter data in vector format? 1 meter. Yes, Katie, thank you for mentioning that. So Katie Walker, who works with the Conservancy and helps lead this project, mentioned when we have our next data release, including the 2021-2022 data timestamp being mapped in June of next year, we'll be releasing that data and we will have an accompanying data release webinar. Okay, thank you for this feedback. I think we have 1 or 2 more questions. So if you're interested in participating in our in the land use work group at the Chesapeake Bay Program, if you want us to send you an email of the link for you to attend, or just want more information, we can send that PDF describing more so what those official roles are if you're interested in. Please go ahead and drop your name and your email. as Jackie put on the slide, we won't be populating the screen with this input. So no one else in the webinar will see your responses here. Right. Because I can't see the responses, I'll let you, Jackie, let me know when responses are slowing down.
Yeah, I'll keep the Menti open so you can still drop your name and email, but I can stop sharing.
Perfect. Thank you so much, Jackie. Thank you so much for all of the feedback. Thank you for attending today. And I will go ahead and pass it off to Jillian to close us out.
Well, we have a few minutes and it looks like a few questions have come in. We'll actually maybe just one that has not yet been answered. Are there any related mapping resources for West Virginia that anyone knows about? And I know you had touched on other states a moment ago, but if you wanted to speak to that more specifically.
For West Virginia, we map the counties in the Panhandle. I think we map 14 counties in West Virginia. That's currently what our mapping region looks like. If it would be of interest and of use for us to map the entire state, that is useful feedback for us to know. So if that's the case, please feel free to drop that in the chat.
Alrighty, well, feel free to drop any last questions, attendees. As I mentioned earlier, there will be an email coming to your inboxes in the next couple of days that will include the webinar recording link and also all the slide decks from each presenter. So you will have these resources accessible to you. We'll also be providing their email. So if you think of any questions that pop up in the next couple of days or want to connect, that will also be available. But thank you very much for joining, everybody. And I will note that I was in touch with APA National because it appears that there were some issues with the CM number. So that number will still be the number to be used. I'm not sure if it has gone live on the CM log list that APA National provides on their website, but that information will also be sent out in the email follow-up as well. But yeah, please feel free to reach out to APA Virginia if you have any questions. Oh, it looks like Sarah Ross has mentioned that the CM number is live and working, so that's awesome. So thank you for confirming that. But thank you everyone for joining, and I really hope you have a great rest of your day. And thank you so much to our presenters. We had such a great turnout, so it really speaks to the importance of this topic, and I'm really grateful for all the presenters' time.
Thank you, Jillian.
Bye, everyone.